Elon Musk is familiar with being in the news all the time, be it because of his companies, his personal choices, or his outrageous tweets. Elon is always up to something new and exciting, and always comes up with some jaw-dropping, humongous plans. This time, he says that nuclear waste will be used in his SpaceX Starship. Oh, and when did this happen? Well, watch the complete video and I'll tell you all about it. Elon Musk is a name that doesn't need any introduction or backstory. We all know he is a Mars enthusiast and a brilliant entrepreneur who breaks norms with his choices, both professional and personal. Elon Musk's SpaceX may be capturing the public eye in 2022, but countless companies around the world are also working on spaceflight and spaceflight components. One of the most recent moves comes from private industry groups seeking to prioritize nuclear-powered spacecraft in future plans to reach Mars. The concept is simple and effective. A tiny nuclear reactor is completely encased, and the only way for energy to escape is through a funneled opening. The low-enriched uranium is split by neutrons, which start a chain reaction, and the hydrogen fuel flowing through is vaporized in massive amounts. This is how thrust is generated. In some ways, it's similar to a directed nuclear weapon reaction with a limiter. Engineers argue that the fuel they use is less volatile, and the reaction itself is less dangerous than the association with nuclear weapons might imply. According to Elon Musk, nuclear energy is considered clean energy because it does not emit greenhouse gases. However, legacy nuclear power plants do have a bad reputation because of a few high-profile accidents. I think modern nuclear power plants are safe, contrary to what people may think, the Tesla and SpaceX CEO said. I really think it's possible to make extremely safe nuclear thrusters. And I'm talking about fission. You don't need fusion. You must be wondering what nuclear fission is. Nuclear fission is a nuclear reaction in which a heavy nucleus splits spontaneously or after colliding with another particle, releasing energy. Nuclear fission is the process used in conventional nuclear reactors. Fusion is the inverse reaction of fission. Smaller atoms collide and join together to form a heavier atom, releasing energy. The process by which the sun generates energy is known as fusion. You've got the sun, which is a massive fusion reactor in the sky. It comes up on a daily basis, Musk explained. It looks like Elon is digging deep into the nuclear stuff. He's been explaining the nuclear processes up and down many times. This shows he is keen to use nuclear reactors in his Starship. Well, this is not the first time Elon has supported the use of nuclear energy, and he has been a supporter of the use of nuclear energy in technology development. Musk didn't go into detail about how nuclear power plants could be made extremely safe. On the other hand, Musk has long advocated for using nuclear energy. We should build more nuclear power plants, Musk told PBS in 2007. I believe that it's a better way to generate energy than a coal or natural gas power plant. According to the U.S. Energy Information Administration, nuclear energy currently accounts for about 20% of total energy generation in the United States. Traditional nuclear energy technology based on fission has evolved and improved over time. For example, Bill Gates founded TerraPower, an advanced nuclear company that is innovating on legacy power plant technology. But the use of nuclear energy is not a favorable choice by many. Some argue that fusion is a safer way to generate nuclear energy than fission, because fission produces radioactive waste that can be dangerous for a long time. In contrast, fusion does not produce long-lived radioactive waste, among other reasons. The issue is that with current technology, fusion consumes all of the energy it generates in order to sustain its reaction, leaving no net energy to power other things. Several companies are attempting to commercialize fusion energy, but have so far been unsuccessful. Nevertheless, the use of nuclear energy has been subjected to risk and danger. During the golden age of the nuclear dream, when people saw nuclear energy as a radical and empowering solution to many problems, scientists and designers imagined nuclear versions of nearly every consumer good. Automakers displayed concept vehicles powered by nuclear reactors. People believed consumer nuclear power could be completely safe and revolutionary, even after the United States dropped 2 nuclear bombs on Japan. William Corliss, a prolific, curious scientist and anomalist, wrote about the possibility of bringing nuclear energy to space. Someday, a rocket will launch a manned spacecraft from its parking orbit around the Earth and propel it into an elliptical transfer orbit intended to intercept the planet Mars 7 months later. Corliss wrote for the Atomic Energy Commission in 1966. Corliss wrote before humans had even landed on the moon, but his arguments for and against nuclear spaceflight are still relevant today. After decades of periodic nuclear plant meltdowns, the public is now wary. Musk suggested last year that nuclear thermal propulsion could shorten the duration of his planned SpaceX Starship trips to Mars. Corliss's 7-month estimate is comparable to what experts now believe is the duration of a non-nuclear journey to Mars. The project started as nuclear spaceflight experts spoke at the Commercial Space Transportation Conference in Washington, D.C. in January. NASA spacecraft development and construction have always been done in collaboration with aerospace contractors such as Lockheed Martin and Rockwell International. For decades, these experts have suggested that the tiny nuclear energy used by some satellites and surface vehicles could be scaled up to power flight. Doing so safely could reduce astronaut risk during the trip to Mars, especially since exposure to ambient cosmic radiation is a major risk. Despite technological advances, there are still risks associated with nuclear power. And the better solution is to focus on increasing renewable energy sources such as wind and solar. And if you look at the fact that a nuclear reactor can be helpful in a spaceship, this is not the first time the idea has surfaced in experts' minds. Rocket scientists fantasized about atomic-powered spaceships in the 1950s. Project Orion was the most audacious, dangerous, and ridiculous space program ever funded by the American taxpayer. To propel a spacecraft the size of the Empire State Building through space, nuclear bombs exploded behind it in the 1950s. The Orion's engine would produce massive amounts of energy, as well as lethal doses of radiation. According to plans, the spacecraft could launch from Earth and travel to Mars and back in just 3 months. The quickest flight time possible with conventional rockets and proper planetary alignment is 18 months. There were obvious difficulties, such as irradiating the crew and the launch site, the disruption caused by the electromagnetic pulse, and the dangers of a catastrophic nuclear accident wiping out a large portion of the United States. Nonetheless, the plan was given careful consideration. When atmospheric nuclear tests were common, and the power of the atom promised us all a bright new tomorrow, Project Orion was conceived. Or perish. Life was much simpler back then. The project was shelved in the early 1960s when common sense prevailed, but the concept of nuclear-powered spaceships has never died. There are several right now in the cold depths of space. The Voyager space probes, which are currently exploring beyond the solar system, and the Cassini spacecraft orbiting Saturn are equipped with nuclear power plants. These radioisotope thermoelectric generators, or RTGs, generate heat from the natural decay of plutonium, which is then converted into electricity. However, despite the multi-billion-dollar global effort that has gone into fusion research over the last half-century, no one has yet built a fusion reactor that produces more energy than it consumes. As fusion engineers usually joke that a viable fusion power plant is always 30 years away, if a viable fusion reactor can be developed, we could see a nuclear-powered ship leaving our immediate cosmic neighborhood for the stars and planets. Even if all of this is feasible, there is one particularly vexing issue. Project Orion's designers faced the same problem in the 1950s. To avoid nuclear fallout, you can build and power up your fusion engine in space, but how do you keep your astronauts from dying from radiation sickness? We hope the scientists can find a safer and more economical nuclear reactor to assemble in the Starship. Nevertheless, nuclear power could be a tool to take us to Mars. What do you think SpaceX will do next? Well, let us know in the comments section. Please like and subscribe to the channel. Do let us know in the comments section about your views. Before you leave, press the bell icon so that you can get notified when a new video comes. Until then, adios.